All right. Good afternoon, everybody. Just let me know if you all are hearing me clearly, please. All right, great. Okay, so good afternoon again, everybody. So this class that we are in here, this is my current Form 4 class, right? Those of you who don't belong to the class, this is just a sample of the class, right? Today I'm going to begin trigonometry, right? This is one of those topics that give students trouble, basically, right? And I must admit that when I did it way back in Form 3, I did have some problems, right? But I do believe it's how the topic is taught and the kind of practice that you get on that particular topic, right? Just keep in mind, do not get discouraged. Trigonometry is pretty straightforward. For the most part, if you have it as a question in your paper 2, you're going to have your calculator to use, right? In previous years, students had to work out questions using something called a three-figure table. But now, everything we're going to use the calculator, right? Once it's a paper 2. So, let me begin. All right, first things first, let me just get a blank sheet here. Give me a sec. All right, so hold on one sec. All right, so first things first, right? I need you all to understand that we have different types of triangles, right? So the first type of triangle that we have looks like this, where all the sides are equal. So let's say we have A, B, and C. This is a triangle here. And all the lengths and all the angles, these angles here, are the same. Can somebody tell me what type of triangle is this called? All right, so I'm seeing Cherie saying it's an equilateral triangle. That's correct. So this here is an equilateral triangle. All right, so in an equilateral triangle, all the angles are the same, all the lengths are the same. Now, we have a next kind of triangle here that looks like this. In this particular triangle, we have ABC again. We have two lengths that are the same and two angles that are the same. What type of triangle is this? All right, so I'm seeing people saying it's an isosceles triangle. That is correct. So this second triangle here, it's an isosceles this is a C-E-L-E-S. So this is an isosceles triangle, right? Then we have a triangle that looks like this. Right, where one angle is 90 degrees. What is this triangle called? Alright, so I seen Sharice and Daryl saying a right angle triangle. That is correct. This is called a right angle triangle, right? So it's called a right angled triangle. Alright. Then we have another triangle that looks something like this. Let's say we have this. Right? In which case all the sides and all the angles are different, right? So if all angles, so all angles different, or lengths different, what do we call this for a triangle? Right, so Darrell is in a scalene triangle. That is correct. So this last triangle here is called a scalene triangle. Right? So here's the thing what we need to do. So we're going to start to talk about, the first thing we're going to talk about or spend a good bit of time talking about is the right angle triangle, right? So I want you all to be able to identify, if you see an examination question, you need to be able to identify what type of triangle it is, right? And you need to understand that first of all. There are different types of triangles. When you look at a triangle, there are different techniques we're going to use in order to determine certain things about the triangle, like angles, lengths, and those kinds of things, right? So we have equilateral triangle, all the lengths are the same, all the angles are the same, right? In the case of an isosceles triangle, we have two lengths that are the same and also two angles that are the same. A right angle triangle has one angle that is equal to 90 degrees, right? So this angle in the right angle triangle is equal to 90 degrees. Then we have another type of triangle called a scalene triangle. All the lengths are different and all the angles are different, right? Now, with respect to a triangle, there are certain things you need to know. Let's say I have something like this. Now, when we are labeling diagrams, we can label like this: A, B, and C, right? You can either go clockwise or anti-clockwise. So these are the labels for the triangle, right? Now, this here, this length here, this length AC, which is opposite to the angle B, we represent that by using a small b, right? In the case of capital A, the side that is opposite that, we label that as small a. And the same thing for C, right? In the case of C, small c will represent this length. Now, when we add up all the angles in a triangle, so we add up this angle, and this angle, what angle, or what is the total that we're going to get when we add up all the angles in a triangle? Right, so Shirish is saying 180 degrees. That is correct. So when we add up these angles, if we add up A plus B plus C, we're going to get 180 degrees, right? So there's something we need to know. When we add up all the angles in a triangle, we are going to get 180 degrees, right? So our topic or our discussion now is going to focus primarily on the right angle triangle. So like I said, when we are talking about a right angle triangle, there's one angle in the triangle which is 90 degrees, right? That's the important thing we need to remember here. So the first thing we're going to look at is something called Pythagoras Theorem, right? So we have something called Pythagoras Theorem, right, which says something. So in this diagram, I have a right angle triangle. I have labeled the vertices of the triangle as A, B, and C. Right? So like we said just now, the side opposite C, we're going to call it small c. So that's what you see in here. This is called small c. The side opposite A, one second, just give me 1 sec. Okay, sorry about that there, right? I may have to run off a little bit in a sec as well, right? So what I was saying is that, so the side opposite C, we're going to call it small c. The side opposite big A, we're going to call it small a. And the side that is opposite angle B, which is across here, we're going to call that small b, right? So here's what Pythagoras' theorem is saying, right? It is saying that the length c squared, so this is the formula that we need to be aware of, right? So c squared is equal to a squared plus b squared. Now, in class, what I usually tell my students to do is try not to necessarily remember the formula, right? The side that is opposite my right angle, right, that's C, that's the side here, it's called my hypotenuse, right? So the side opposite my right angle is called my hypotenuse. So how you should try to remember the formula is remember it as the hypotenuse squared is equal to the sum of the squares of the other two sides, right? I want you to try to remember the formula like that. So my hypotenuse, so this is Pythagoras Theorem we're talking about here. My hypotenuse squared is equal to the sum of the squares of the other two sides. Now there's a reason why I'm telling you to remember it like that. When in the exam, when you get a question, they might label the question and they will say P, Q, and R or PT and S instead of using A, B, and C. And when students see that, they get confused because they are trying to apply a formula that does not match what they are seeing, right? So try to remember it in terms of my hypotenuse squared, which is the longest side in the right angle triangle, is equal to the sum of the squares of the other two sides, right? So this same equation here, I can write this over as AB, which is a length, squared is equal to BC squared plus AC squared, right? Now this is just another way of writing the same equation. Both of them mean the exact same thing, all right? So let's look at an example, how we're going to use Pythagoras' theorem now. So let's say we have a right angle triangle here, and we have two lengths, right? We have the lengths on either side of the right angle triangle, and I want to find the length AB. Now before you can use Pythagoras' theorem, the triangle must be a right angle triangle, right? So at the beginning, we spoke about different types of triangles, because some students, if they're given a question in the exam and they look at a triangle, they'll be like, oh, so yeah, we're going to just use Pythagoras'. But you cannot use Pythagoras' theorem if it is not a right angle triangle, right? Keep that in mind. So this is a right angle triangle here because this angle here is 90 degrees. So first thing we need to do, before you can apply Pythagoras' theorem to find any length, right? We must first write down in terms of the diagram they've given to us what the equation is. So I just told you all, it is the hypotenuse squared, right? So I'm going to write it down in terms of the diagram they've given me. So AB squared is equal to the sum of the squares of the other two sides. So you can write it as AC squared plus BC squared, right? This is what Pythagoras' theorem is. So we've written down what the formula is because the question wants us to find AB. So we can say that AB squared is equal to AC. In this case, AC is 8 centimeters. So it is 8 squared plus, it's always going to be a plus in the formula, BC squared. BC in this case is 4 centimeters. So this is going to be 4 squared, right? So you're going to write back again, AB squared is equal to 8 8s 64 plus 4 4s are 16, right? So therefore AB squared is equal to 64 plus 16. This will give me 80, and therefore AB is simply equal to the square root of 80. Therefore AB is equal to, and if we work that out, we're going to get 8.94 centimeters, all right? And this will be my length AB, which is my hypotenuse. That's what I'm trying to work out here. Now, one of the problems that students have when they are writing up their solutions, they write what we would say crap foot, right? They are not trying to write as neat as they possibly can. Please, proper statements are important in maths, right? If you notice, I try to keep my equal sign under equal sign. I try not to leave out steps. I try not to work out things in my head right? I want to write step by step how I am going to work this problem. So in the exam, if you are given this exact question, this is how I would write my answer, right? In order to achieve full marks. You see, the thing is, if you show the steps and you're working, right? But somehow you press something wrong in the calculator, right? The examiner will see that you knew what you were doing, but you made a mistake, right? You can get almost full marks for the question even though you made a mistake in the final answer, right? So step-by-step working is extremely important, okay? So, any questions on how I work this one? Right, so all we are doing here, you're following my steps in order to work this problem. Now, let's look at a second example. So this particular example, they've asked us to find the hypotenuse, right? Now, if we look at this next example here now, we have two lengths, right? It's a right angle triangle, and we want to find BC. So again, this is 90 degrees here, and the question wants us to find the length BC. So first of all, if they give you the question, you have to determine, can I really use Pythagoras Theorem? In order to use Pythagoras Theorem, the triangle must be a right angle triangle, right? We must have two sides in the triangle to be able to use the theorem, right? So first things first, you need to write the theorem in terms of the triangle they've given us. So the longest side is my hypotenuse, which is the length AB. So we're going to write that. We're going to say AB squared is equal to the sum of the squares of the other two sides. So let's write AC squared plus BC squared, right? So AB squared, now we're going to plug in numbers now. So we're going to say 8 squared is equal to AC squared, which is 6.5 squared, plus BC squared, because we don't know what BC is. BC is what we want to work out in the question. So all right. So what we can do, we can write, so some students can manipulate this very easily. So I'm going to show you the easiest way to do this. You can write 6.5 squared plus BC squared is equal to 8 squared, right? You're not changing any sign as yet. Just look at it. If I have 8 squared is equal to 6.5 squared plus BC squared, it means that 6.5 squared plus BC squared is equal to 8 squared. All right. Now we can start to manipulate the equation now. So we can say BC squared is equal to 8 squared minus 6.5 squared. Right. So now we're going to use our calculator now. So 8 eighths gives us 64 minus 6.5 squared. So this is 6.5 squared, and this gives me 42.25, right? So BC squared is equal to 64, take away 42.25, and you're going to get 21.75. So you're going to get 21.75, and therefore BC is equal to the square root of that, 21.75, all right? So therefore BC is equal to, and use your calculator for this part, you're going to get 4.7 centimeters, right? So your length in this particular case is 4.7 centimeters. All right. So this is our second example on how we do Pythagoras Theorem. So just to make sure you all are getting a chance, I want you all to work out the length BC for this particular triangle, right? So I want you to work out the length BC. I'll give you 2 to 3 minutes to work that out for me. I want to see what you all get. So calculate the length BC for me. All right. I see Shiri's worked it out already. She got 7.9. Now, if you are given a question like this in the exam, typically they will tell you if to give your answer to 1 decimal place, 2 decimal places, or to a few significant figures, right? So pay attention to when they ask a question like this, right? I've seen students, if they work this out, they might give the answer 7.91235, right? So pay attention to how they want you to give your answer, right? So let's take a look at this now. So we want to calculate the length BC, right? So the first thing, so we know we're going to use Pythagoras Theorem here, right? We don't have any other angle besides the 90 degrees. So we're going to start off with the hypotenuse squared, which in this case here is AB squared is equal to AC squared plus BC squared, right? So AB squared in this case would be 11.2 squared is equal to AC, which if you look at the diagram, it's 7.9. So it's 7.9 squared plus BC squared, right? Just like in the previous question, we're going to write this as 7.9 squared plus BC squared is equal to 11.2 squared, right? Now we're going to say BC squared is equal to 11.2 squared minus 7.9 squared. So therefore BC squared is equal to, so you can work this out in one go if you want, or you can do it separately. Work out the 11.2 squared, right? So I'm going to work it out in one go. 11.2 squared, that gives me 125.44. Take away 7.9 squared, and I'm going to get 63.03. So you're going to get 63.03. So therefore BC is equal to the square root of that. So that's the square root of 63.03. And you're going to find the square root. So therefore BC is equal to second function, and you're going to get 7.9 centimeters, right? So Shirish was correct. The answer is 7.9. You can give your answer 7.94. That is fine. So you can put 7.94 at 7.9. So this is my answer to 2 decimal places, right? If they wanted me to give the answer to 1 decimal place, then it will be 7.9. So it depends on what they are telling you in the question, right? But the answer is 7.9 or 7.94, right? All right, give me a sec here. I feel I'm missing a page. All right, so I had a slide here and it seems to have disappeared, or maybe I accidentally deleted it. So let me just get a okay, so yeah, I'm missing a slide here for some odd reason, right? Okay, so let's go back to our right angle triangle, right? So I'm going to label my triangle here ABC again, right? Now, we're going to talk about what we call our trigonometric ratios. So we have something called the sine ratio. We have something called the cosine ratio. We have something called the tangent ratio. Right? So this particular topic is what gives students some trouble, right? So first things first, we need to understand something about the triangle, right? When we're going to use which ratio and how do we treat with things, right? So the first thing, this is my right angle triangle here, and this is my 90-degree angle. Once you know where the 90-degree angle is, then we know that the side opposite the angle, the 90 degrees, is my hypotenuse, right? That is always going to be my hypotenuse. Now, in order for us to use the sine, the cosine, and the tangent ratio, we must have an angle other than the right angle triangle in the triangle. So this angle here, right, if you've never seen this symbol before, it's called theta, right? And so this is a symbol, it's a Greek symbol, it's a Greek letter, right? It's called Theta, right? It's a symbol that we commonly use to represent an angle in maths, right? There are other symbols that we use as well. We can use something like this, right, which is called alpha. So this is just a symbol, right? But the one that we tend to use a lot is the first one, which is theta. So in this triangle, we have the angle theta inside here. Now, here's what I need you to understand. The side that is opposite my angle, right, which is the side AC, we're going to call that my opposite. This is my opposite side, right? So you know how to identify the hypotenuse. It's the side opposite the right angle. The side opposite the angle is called my opposite. And the side what we call adjacent to the angle, that is this here, we're going to call that my adjacent side. So here's how you do it. It's easy to identify the hypotenuse. To identify the opposite side is easy. So the side that I'm left with is what we call my adjacent. Now, these ratios, right, they mean different things. So for example, sine theta is equal to opposite divided by hypotenuse, right? That's something you have to know. Sine theta is equal to opposite over hypotenuse. All right? Now we have something called cosine as well. Cos theta is equal to adjacent, ADJ, over hypotenuse, right? That's what the cosine ratio is. And the last ratio is something called my tangent ratio, which is tan theta is equal to opposite over adjacent, right? So sine, cosine, and tan, those are ratios of lengths of a right angle triangle, right? That's what it is. Don't get confused by it. It is not difficult. Trust me, it's not difficult. It only looks that way, but it's not. So first things first, we need a way for us to remember each of these formulas, right? So all I use is this. We say so, ka, toa, right? This is what I use, right? So some of you all may have something different in school. So this is something I use. So, ka, toa. So look at this first thing here. SOA means sine is opposite over, oh sorry, I made a mistake, yes. Yes, no. Let's write that over. So, ka. Right. Yeah, so back to what I was saying. So sine is opposite over hypotenuse. For this one here, cosine is adjacent over hypotenuse. And for this one, tan is opposite over adjacent. So what I want you to do, I need you to remember this here. Once you remember that, you're going to remember this formula, you're going to remember this formula, and you're going to remember this formula, right? That's what you need to remember. So sine, cosine, and tan, that is ratios, right, of lengths in a right angle triangle. I need you to understand that concept first of all. That's what it is. It's just a ratio of lengths, right? Now, let's look at an example. So the first one we're going to look at sine, right? So we're looking at the sine ratio. There are three different questions they can bring on each of the triangles or each of the ratios. So the first one here, we have a triangle, right? Before I can use the sine ratio, cosine ratio, tangent ratio, it must be a right angle triangle. I've seen students come to me and say, sir, this is how we're working this out. And I'll be like, no, it's not a right angle triangle, all right? There are other rules that we use when we have a triangle that is not a right angle triangle. So look at this. So they want us to find the angle theta, right? So we have two lengths and we have an angle that we want to find. So the first thing, before, this is the thought process that has to go through your mind. Look at the triangle. Is it a right angle triangle? Yes, it is. Do we have an angle inside the triangle that we want to find? Yes, we do. We want to find the angle theta. So now you need to label your triangle to make sure you understand in your mind. So the side opposite my angle, it's called my opposite. The side opposite the 90 degrees, that's here, is called my hypotenuse, right? This is my hypotenuse. So in your mind now, you need to figure out, so which one of the ratios do I need to use? Do I need to use sine? Do I have to use cosine? Do I have to use hypotenuse? Look at what they've given us. We know what the hypotenuse is. We know what the opposite is. So keep in mind, SOH, so, ka, toa, right? So I have opposite and I have hypotenuse. So obviously, because I have those two things, I'm going to use sine. So this is how you write up your answer for this particular question. First thing we do, we write up what the ratio is first of all. So sine theta is opposite over hypotenuse, right? That's the first thing we need to do. Sine theta is opposite over hypotenuse. Now, sine theta is equal to, we're going to substitute values now. My opposite, I already have it labeled on diagram. It's 7.1. divided by 8.3. So sine theta is equal to, so here's what you're going to do. You're going to just use your calculator and just take 7.1 divided by 8.3. So 7.1 divided by 8.3. And what you're going to get is 0.855. So what I want you to do when you're working this question, you can work, you see this piece here? Work that to 3 decimal places. Now, when you reach a stage here, you need to find what the angle is. Now look at how we write this. What we are going to do is find the inverse sine of 0.855 in our calculator. To do that, this is how we're going to write the statement. So we're going to put sine to the power minus 1, open brackets, 0.855, right? This is how we write this, right? Then I'm going to have to use the calculator. So those of you who have a scientific calculator, you're going to press second function, sine of 0.855, and that is going to give me an angle, right? That is going to give me 58.8 degrees. Again, in the question, they're going to tell you if they want the angle to the nearest degree or to 1 decimal place, right? So in this case here, I've worked out the angle using sine. We're using the sine ratio. Please keep in mind, for those of you may have done this before, this is not the sine rule, right? We are using the sine ratio. This is how we write up the statement, right? Exactly how I've written it here is how you're going to write the statement. So let me ask. So are you all okay with this calculation? All right, so if you want to get full marks in your paper 2 in particular, this is my working. This is how you're going to write up your answer. All right, so I'm going to do our next one here. So look at this. So we have a right angle triangle. How do we know that? We know that this angle here is 90 degrees, and we want to calculate the length BC, right? That's the length that we want to calculate. So the first thing we need to do, they've given us an angle. So we need to label the triangle. So this side here is called my opposite. You have the right angle triangle, So this here is my hypotenuse, right? So this is how I work it if I have to work this question, You have to label what are your sides. So look at something here. So go back to what I'm telling you. SOA, keep it in SOA, SOH. SOH, CAH, so SOCA, TOA, right? That's what you're starting off with. So you have to look and see. I have hypotenuse, I have a value. I have my angle. I want to work out what is my opposite. So if you have opposite and you have hypotenuse, it means that I must use sine, right? This is a challenge for some students. They look at the question and they are confused as to what we are supposed to use. I'm going to use sine because I have hypotenuse and I have opposite. So you start off by writing what the sine ratio is. Sine theta is opposite over hypotenuse. That's what the sine ratio is. So then we're going to say sine 60 degrees, because that's my angle, is opposite, which we don't know, right? But we can label it as BC. That's what the question wants. The question wants BC. Divided by my hypotenuse, which is 9.4. Now, this is the part that confuses students. I will not lie to you. When I was in Form 3 and I was doing this for the first time, I was kind of a little confused as to what we were doing. So you want to calculate the length BC. So here's what you need to do. You see on the left-hand side, that's sine 60. I can write that as sine 60 divided by 1, right? Then what we're going to do, we are going to cross multiply. That's what we're going to do. We're going to cross multiply. So what does that mean? It means that this sine 60 multiplied by 9.4 is equal to BC multiplied by 1. So if you all have never seen this before, this is what cross multiplication is. If I have A over B is equal to C over D, that is one fraction equal to an next fraction, I can cross multiply and say that A multiplied by D is equal to B multiplied by C, right? This is something that is extremely important that you need to know, right? Because this is going to help us to work this question out. So I'm going to cross multiply, but because I want to find BC, I want BC to be on the left hand side. So I'm going to do BC multiplied by 1, which will give me BC, which is equal to 9.4 multiplied by sine 60 degrees. So BC is equal to, I want you all to work this out on your calculator, get the feel for working out sine on your calculator. So work out that answer for me here using your calculator. I want to see what answer you're going to get. Alright, so I see Shiri's got 8.14. Let me see. Alright, Danica also got 8.14. So let's see. So 9.4 multiplied by sine 60. Yeah, so the answer is actually so the answer is actually 8.14. Alright, so 8.14 is the answer. That is the length BC. Alright. So cross multiplication, you need to know how to do that. So let's look at a third example here now. I want you all to work this one out. So I have a length 5.7 centimeters. I have an angle which is 40 degrees. The triangle is a right angle triangle, and we want to find length AB. So I'm going to give you a couple of minutes to try to work this out for me. So you're all following the same principles that I just showed you there, right? First thing, you must identify if I'm using sine, cosine, or tan, right? In order to do that, you must label the triangle first. And then when you label the triangle, then you can start working the problem. What? Shiri's moving real fast, right? So Shiri's got 3.66. Let's see what other people are getting before I work it out. All right, so I'm seeing a lot of you all getting 3.66. So let's see. All right, so first things first, we need to label the parts of the triangle, right? So this is my right angle triangle, so therefore the side opposite is called my hypotenuse. We have 40 degrees here, so this side opposite the 40 degrees is called my opposite, right? So therefore this last side here is my adjacent. So first things first, you need, so it's ka tua, right? So I have my opposite side here, which is 5.7. I have the angle, and the question wants me to find AB. So what is AB? AB is my hypotenuse. So therefore I'm using hypotenuse and I'm using opposite. So therefore I have to use sine. So we start off by writing sine theta is equal to opposite over hypotenuse, right? So sine theta is equal to opposite over hypotenuse. So we know the angle is 40 degrees. So sine 40 degrees is equal to my opposite side, right, which is 5.7. 5.7 divided by my hypotenuse, which I don't know what it is, but we know it is AB, right? So all we do now, so we're going to put sine 40 over 1. This will allow us to be able to cross multiply. For those of you who don't understand what I'm doing here, if I have the number 5, right, and I put 5 over 1, the answer is still 5. I'm not doing anything with it. All I'm doing is writing the sine 40 as a fraction. I'm writing it as sine 40 divided by 1. So I'm not changing anything really. I'm just expressing it as a fraction. Now we're going to cross multiply. So we're going to say this by this is equal to this by this, right? Now, since I want to find AB, I need to have AB on the left-hand side. So how I'm going to write this? I'm going to write it as AB multiplied by sine 40 degrees. So for those of you who've never done this before, this is how we write the statement. We put AB first, and then we're going to put sine 40 is equal to 5.7. So now we're going to work out AB. So AB is equal to 5.7 divided by sine 40 degrees, right? So what we're going to do here now, we're going to just use our calculator. So 5.7 divided by sine 40 degrees, and you're going to get 8.87. So we're going to get 8.87 centimeters. All right, so let me see what you all put. So only one person got the correct answer here, which is Josiah. All right, you all got 3.66. How did you all get 3.66? It means that you all may have done the division wrong. 5.7 multiplied by 6. Right, so when you all did the cross multiplication, you did the cross multiplication wrong. All right, are you all seeing the mistake in your calculation based on what I showed you here? Alright, so Danica is saying she knows what the mistake is. BC is... Yeah, BC is 5.7, yeah. Alright, so you need to be very careful with this cross multiplication that we are doing here. Okay, now let's look at our next question, right? So let's look at this here. So we want to find the angle theta, right? So I have, so this is my angle here. So the side opposite this angle here is called opposite, right? And if we look carefully, if that is opposite, this side opposite here, opposite the right angle, is called my hypotenuse. So this is my hypotenuse. And therefore the last side here is my adjacent, right? So if you look carefully, I have hypotenuse and I have adjacent. So which ratio am I using here? Chantel, don't worry, we will see some more questions. You'll get practice. That's what I said. Trigonometry could be tricky at first, but you see this cross multiplication thing, you need to understand this first of all, right? I am telling you, when I did this a long time ago, I had problems with it, right? And I had problems, you see, especially that particular question that you all got wrong, I had problems with that, right? One second. All right, so I'm seeing you all saying cos or cosine, right? So that's true. So if we look SOH, so ka tua, right? So I have hypotenuse and I have adjacent, so therefore I should be using cosine, right? So here's what I'm going to do. I'm going to say cos theta is equal to adjacent, so ADJ over hypotenuse, right? That's how we're going to start it off. So we start off by writing what the ratio is first of all. So then we're going to say cos my angle, which I don't know what that angle is. It's theta. My adjacent now, in this case here, is 8.4. So this is 8.4 divided by my hypotenuse, which is 11.0, right? So now we're going to work that out. So cos theta, you're going to use your calculator to work this out. 8.4 divided by 11. And this gives me, we're going to write this answer to 3 decimal places, 0.764. And now in order to get theta, theta is simply the inverse cosine of 0.764, right? So we're going to use the calculator to work that out. And when we work that out, we're going to get 40.2 degrees, right? So this is how we work a particular question. If we have if you have to work out an angle and it's the cosine ratio we're using, right? So when you get a question like this where they ask us to find the angle, this is the easiest type of question they can give us, whether it's sine, cosine, or tan. It's the easiest one they can give us, right? Yeah, Danica, I know it was cosine ratio at the top. I saw that. Yeah, I know. All right. So yeah, we know we're using cosine for these, right? So here's what I want you to do. I want you to work this one here. I want you to work out the length AC for me. So I want you to work out the length AC. I'll give you a few minutes to work that out. Alright, let me see something. Chat, so my calculator saying, think I'm doing something wrong. The calculator telling you that, chat, or is it that you are doing something wrong? Now, you all need to be able to use the particular calculator that you have, right? The one that I typically use and I advise students to get because it's rather cheap. It's called the Sharp Dial Calculator. It's about $100. So students will realize how powerful that calculator is. That calculator can work out simultaneous equations. The calculator can work out fractions. Alright, so I've seen a lot of you again. 7.62. Alright, so we have an angle. So the side opposite the angle, we're going to call that my opposite. The side opposite the right angle, we're going to call that my hypotenuse. So therefore, this side here is my adjacent. Right? Now you want to get AC. So AC, based on the diagram, is adjacent. So we're working with adjacent, and you know what the hypotenuse is. So therefore, we have to use cosine. So cos theta is equal to adjacent over hypotenuse, right? So cos 30 degrees is equal to adjacent. Adjacent is what you don't know. So that is going to be AC divided by my hypotenuse, which in this case here is 8.8. Now, at this point here, we're going to write cos 30 as cos 30 over 1 because I'm going to have to cross multiply, right? So what we're saying is that this multiplied by this is equal to AC by 1. But I want AC to be on my left-hand side. So therefore, AC is equal to 8.8 multiplied by cos 30 degrees. So therefore, AC is equal to, and you're going to work that out. So that is 8.8 multiplied by cos 30. And you're going to get 7.62 centimeters as the answer. Alright? So let me see what you all getting. Alright, so you're getting 7.62. Please do not round off your answer to 8. Right? 7.6 could be your answer or 7.62. So Chad, I want to know if you understand the working that I've done here. Chad, talk to me. Let me hear. All right, Josh. All right, cool. Right, so this is how we work a question where they've given us a length, they've given us the hypotenuse, and they want us to find the adjacent, right? So for this one, the answer is 7.62. I'm going to give you another one here that I want you to work. Please be careful. This is similar to the one you all had problems with just now. So I've given you a right angle triangle and I want you to find the length AB for me. Chad, send me the model of the calculator that you're using, right? And I'll get back to you as to how to use it. There are some calculators where you have to type COS first and then press the angle. And then there are some calculators where you press the angle first and then you press COS, right? So it depends on your calculator. So I want you all to calculate the length AB for me. All right. So I'm seeing two different set of answers. So some of you are working it right and some of you all are still working it incorrectly. Some of you are getting 12.6, some of you are getting 3.15. All right. So let's see. Alright, by the time you finish your class, you'll know exactly what you need to do. So, first things first. The side that is opposite the angle, it's my opposite. Right? The side that is opposite the right angle is my hypotenuse. And therefore, what I'm left with here is my adjacent. Right? So, we have the adjacent length. The question wants us to find AB, which is my hypotenuse. So therefore, it's going to be cosine. So cos theta is equal to adjacent over hypotenuse. Alright, that's the formula we're using. So cos 60 degrees is equal to adjacent, which is 6.3, divided by my hypotenuse, which is what I don't know. I don't know what the hypotenuse is. So let me just put AB one time. So this is AB. Alright? This is AB. So we know we're going to have to cross multiply. So put this cos 60 over 1. Right? So we're saying this by this is equal to this by this. So I'm going to say AB multiplied by cos 60 degrees is equal to 6.3. Therefore AB is equal to 6.3 divided by cos 60 degrees, and therefore AB is equal to, and we're just going to work this out. So 6.3 divided by cos 60, and you're going to get 12.6 as my answer. Alright, so the answer is 12.6 centimeters. Alright, so 12.6 is correct. Those of you who have got that, that is correct. Alright, so that's the cosine ratio. Those are three different questions they can ask regarding the cosine ratio. We have a next one here. For this particular one, right, I want you to work out this angle for me here. Work out the angle theta for me. Yes, Josh, you have to divide. Based on how we cross multiply, you're going to have to divide to get your answer. So I want you all to look at this diagram, right? Label the diagram first of all. Identify what's your opposite, what's your hypotenuse, what's your adjacent. Decide what you're going to use, right? And then work out the angle theta for me. Tell me what you get. All right. So Danica saying she got 33.9. Cassion saying 42. Somebody saying 41.87, 33.86. Ooh. All right. All right. So the first thing, well, obviously, I kind of told you here that we're using the tan ratio, right? But the first thing you should do when you get a triangle is to label it. So we have an angle here. So therefore, this here is my opposite. The side that is opposite my 90 degrees is always my hypotenuse. So this is my hypotenuse. And therefore, the side that I'm left with here is my adjacent, right? So now, so we have opposite and we have adjacent. So that is TOA, right? We're going to use this. Tan is opposite over adjacent. So we start off by writing tan theta is opposite over adjacent, right? So keep in mind exactly how I'm writing out the solution here is what you are expected to write in the exam in order to get full marks. So pay attention to what I'm writing. So tan theta is equal to opposite. In this case here, we know the opposite is 5.3. So the opposite is 5.3 divided by my adjacent, which is 7.9. So therefore, you'll have to cross multiply here. We're finding the angle. So tan theta, we're going to take 5.3 divided by 7.9. And you're going to get 0.671. Therefore, theta, all right, is 0.671. So we're using our calculator to work this out, right? This is called arctan. So second function tan, I'm using the calculator to work this out, and my angle is 33.9 degrees. Alright, so my answer is 33.9 degrees, right? When we're dealing with degrees, you can either give your answer to one decimal place or to the nearest degree. So I will accept 33.9 or 34 degrees, right? We don't need to go to two decimal places, right? So this is how we work this out, right? Obviously, if you round off too early, your answer is going to be slightly different, right? So this is how we work this one, and this is my angle in this particular case here, 33.9 degrees. Okay. So let's look at another one. So I want you all to calculate the length BC, right? First things first, draw the diagram quickly. You know, taking a ruler or anything, just sketch the diagram and label what is opposite, what is hypotenuse, what is adjacent. So I want you to calculate BC for me. All right. Right. So Chad saying it worked. Thanks. Okay, good. All right. So I'm seeing you all getting 5.63. Let's see. So first things first, we need to label the triangle. So this here, the side opposite the angle is called my opposite. Side opposite the 90 degree, we call that my hypotenuse. And therefore what we're left with here is my adjacent, right? Now, what do we want now? So we have adjacent. You want to find BC, so we working with opposite. So if we working with opposite and adjacent, we know we have to use tan. So you're going to put tan theta is opposite over adjacent. So therefore tan 56 degrees is equal to opposite, right, which we don't know but is BC. So you put in BC divided by adjacent, which in this case here is 3.8 cm, right? So again, we know we have to gonna have to cross multiply. So tan 56, you can write that as tan 56 over 1, right? So if we cross multiplying, this is what we're gonna do. So BC by 1 gives me BC, which is equal to 3.8 multiplied by tan 56 degrees. So therefore BC is equal to, and you're gonna work that out. All right, when you work this out, you're gonna get 5.63 centimeters, right? So for those of you who got 5.63, the answer is 5.63. Seeing Chantel saying she not getting to the 3.9. That's the previous question. Right, so one of the problems is that you all need to make sure there are three different functions in your calculator: degrees, radians, and gradient. You need to make sure your calculator is always in degrees, right? Sometimes if somebody interferes with the calculator, it may not be in degrees. Okay? So I want you all to work this last one here, which is, one second, PC. Yeah, so I want you all to work this last one here for me. I want you to calculate the length BC, right? I'll give you a few minutes for this one. All right. Let's see. I didn't get a chance to look and see what you all did. All right. So I see most of you all got an answer. Let's see. So first things first, we need to label the triangle, right? We need to label this. So I have the 48 degrees here. So this side here is my opposite. This is opposite. The side opposite my right angle is always my hypotenuse. Right? So therefore what I'm left with here is my adjacent. Now we have opposite, right? You want to work out BC, but BC is my adjacent. So if we have opposite and adjacent, we know we have to use tan. So tan theta is equal to opposite over adjacent. Right? So therefore tan 48 degrees is opposite, which is 8.2, divided by adjacent, which we don't know, which is BC. All right, again, we're going to have to cross multiply. So put tan 48 over 1. So we're going to cross multiply this way. So if we cross multiply, we're going to end up with BC multiplied by tan 48 degrees is equal to 8.2. So therefore, BC is equal to 8.2 divided by tan 48 degrees. So therefore, BC is equal to 8.2 divided by tan 48, 8.2 divided by tan 48, and you're going to get 7.38 centimeters. All right, let me see, did you all get that? 7.38. So most of you all got 7.38, right? All right, so this is how we work this out. Now the thing is, the calculations concerning the right angle triangles, when we have to use sine, cosine, and tan, there are three basic things they can access. They can access to find the angle, or they can access to find one of the sides where we simply have to multiply, and they can access to find one of the sides where we have to divide, right? But the key thing here is to remember we're going to have to cross multiply, right? And proper statements, please. All right, so take a look at this. Sometimes when you get an exam question and you look at it, right, you're not sure what you have to use, right? So for example, in this first diagram here, the diagram on the left, right, I have an angle, I have a side which is 9.3 cm. If I were to ask you to find BC in the first diagram, right, BC, which ratio do I have to use in order to find BC? Sine, cosine, or tan? So which ratio do I have to use to find BC? So people saying sine. You all disappointed me a little bit more. Sure is sine? Everybody saying sine. Oh, it's BC I want to find, you know. BC. Look at where BC is. It's diagram. This diagram we're talking about here, this one on the left. before you can answer that question, you need to label the diagram, right? So this here is opposite. This here has to be my hypotenuse. And this here is my adjacent. That's what I'm left with. So I'm asking you to find BC. In order to find BC, right? And BC is this. That's adjacent. I don't remember seeing adjacent in the sine formula. Yeah, the answer is cos. It's cos we have to use. So it's cosine, not... So we're using cosine for this one. What about this one here? What about this one? I'm going to find BC in this case. So looking at this diagram here, what are we using? Sine, cosine, or tan? Alright, so I saw PS said tan. Alright, so I seen you all saying tan. So before you can answer me, you have to label diagram. So you know this angle, the side opposite this angle here is opposite. You know that this here is hypotenuse. Right? So therefore what I'm left with here is adjacent. Right? So if you want to find BC, you have to look and see where is BC. BC is this side here. BC is adjacent, but I have opposite. So therefore I have to use tan. So the answer is tan. You all are correct. Alright. So you all are correct. Alright. So guys, I need to wrap up a little earlier today. Have a little emergency at home here, right? So I will stop here today. Next week when you all come back, we will practice more questions on sine, cosine, and tan. Alright, so please review. The video will be up. Please review the video so that you all will know what to use when. Alright, so in this class we looked at Pythagoras's, we looked at sine, cosine, and tan. Alright, and like I said, those interested in joining the class, you can message me at 868 784 2059. Right, this is the Form 4 class. Right, those of you in Form 5, the Form 5 class is in progress. We are reviewing our work right now, and they are practicing multiple choice. Right, so you can message me if you're interested in joining any of the classes right now. All right, so have a great night, people, and you all take care.